snapshot here to the right. So the idea here is that the lead engineer or the design manager or whoever is in charge of creating the structure and the framework for your assembly, that person's going to develop the skeleton model. So, multiple designers and engineers may have input in what should be placed in that skeleton model, but for the most part, the design engineer that has the most experience in your assembly design is going to create this skeleton part. So in this sketch up here, you can see that he's developed a framework of sketches that will drive this Husky Razor, and it all starts with him. He creates that sketch, and then there's designers that work on the individual components like the handle and the blade latch, and there's also the fasteners that have to be assembled to the assembly. But the goal here is that the skeleton framework is created. That skeleton framework is shared into the individual parts in this case, so that when the skeleton is updated, all those components update in the assembly without any errors or problems. All right. Okay, so I'm going to go ahead and jump to Creo and get started here. All right, and I'm first going to show this example of a skeleton model. This was a skeleton that I created for my Creality Ender 3 S1. I'm sure the guys here that have joined are in engineering, so some of you may have a passion for 3D printing or 3D print at your job for prototyping. So this is my Ender 3 S1 printer, and I've built this assembly, right? That's an enclosure for my printer. So you can see here that I have a skeleton part at the top of my assembly tree, and the skeleton part is always at the top of your assembly tree. And the great thing about it is no matter what you put in here, even if you have solids in here, this will never add to the weight or the mass of your assembly. To create your skeleton, you'll go to Create up in the component group, and it'll be right here. This is your skeleton model. So once you create that, it'll place it at the top of your assembly. So what's great about this is I can place anything in here, right? I have my datum planes and coordinate systems. I have sketches and surfaces here, for example, for my enclosure. And what I've done is, I'm sure many of you have heard of the advanced framework extension, is I've used the skeleton model to drive all the components that I assembled using the advanced framework. So the framework has a library of profiles. So there's different beams in here. There's an 80-20 10 series. So what's cool about this, there's different profiles and models, and basically you select the profile you want, and then you select the sketch in your skeleton model, and it'll assemble it for you. And you may have to create some joints and trim off some things, but that's very easy with all the basic joints. So I won't spend much time in there. Just wanted to kind of show you where I got these components for my framework here. But what I want to show you is the power of this, right? So we have multiple parts in here and assemblies, but I can drive all these components using my skeleton part. So for example, if I take my leg height plane here and I modify the height, let's do 36 and regenerate, right? You can see that everything updated with it. If I take my top sketch that basically creates the platform size for my printer, I can modify that stuff as well. Regenerate, and everything else updates based on those changes. And that's because all these components here have an inheritance feature where they basically copy in all this data from the skeleton model into these individual parts. I could even adjust the platform. So if I grab this guy here and I change that from a depth of 24 inches to 48, regenerate, that updates. You can also see that these stairs also updated to include more steps, right? I can grab a datum point here and I can move that. I can grab this one to modify the height of that to a ratio of 0.75 and regenerate, right? And now that stuff's going to move down. So this is one example. Let's shift to another. So this is the Husky Razor that you saw in the slides. So same thing. Now in this case, we're not using any datums like the planes and stuff to like drive the positions of the assembly components, but we're just using sketches. So for example, you can see I've got my top profile sketch, my bottom profile, the front curve that drives the shape of the front of this handle. So all these sketches were created. And then if you look down here, you can also see that we have these external copy geometry features. And basically what we've done is we've copied all this data, these sketches, into the parts using these copy geom features. If I edit those, you can see that that's exactly what we did, right? So we grabbed these published geometry features that contain the sketches from the skeleton, and we brought them into the parts. So now if I go up here to my top profile, for example, and I change that angle, let's say to 58, regenerate, a multitude of components just updated to that change. So the handle changed, the pivot mechanism as well, right? The blade latch, everything that has an inheritance feature from that top profile. Any one of those components that updated from that top profile are here. So I just want to pause here and see if you guys can see the power of this and how you might use it. And I'll let Mark chime in as well, or Jim. I think Mark's ready to say something.
No. This is pretty good, and it's a common, I guess, miscommunication that this specific functionality is only used on massive assemblies. So it's good to see how it affects smaller assemblies as well. And I know some of the guys on here have similar products, so I'd be eager to hear some feedback if guys are paying attention or what their thoughts are.
Absolutely, and that's a great point. So if this, say that we're designing a car here, right? We have like the steering system, we have the engine, suspension, braking system, right? So we have all these different components and assemblies that make up this car, right? So for example, you may have a skeleton structure that has different tiers or levels. So maybe you have like the top level skeleton that just drives the placement of the larger assemblies with coordinate systems, right? And then you may have subskeleton models that drive the sub-assemblies of the car. So a lot of thinking has to go into place. A lot of people are like, oh, it takes time to set up this skeleton model. We don't really have that time. We just have to get started and start making these parts and then do the bottom-up assembly approach. That's understandable, but what happens is, if you don't use a skeleton model, and you have a larger assembly and everybody's working and then finally trying to assemble these things together, when you do have to go back and make, mid to late stage changes to your assembly, there's a lot of rework that happens, right? This person has to adjust this assembly or this part to make it fit and this other part. So if you can spend more time up front developing your skeleton part so that it contains the necessary data to drive the creation of the assembly in a way that's more efficient, so that when you make changes, it won't take so long for everything to update the way that it should. If you take that time up front, it may take a little bit more time to get started, but it'll save you more time in the long run. That makes sense. Tim Wang, do you have any questions or comments?
Uh, can you hear me?
Yes.
Hey, hi Bill, how are you? And Mark,
Good.
how are
And
you?
you?
Good.
Excellent.
Yes, I think this is a very great great function. This is the first time I learned the skeleton. I think this is very useful, but in my past experience, when I making the assembly for the product design, we usually will build up a ID master file or master ID for the first model. So that will be kind of a simple form for all the kind of all the like form for the product, then it's kind of a define the first step. Then we cut every part as a, we use like maybe like merge heritage, or we use the copy geometry to different assembly parts. Then we assemble it together using the same coding system. So when we modify the ID master, then it can generate all the different parts all together because it's all related to the ID master part. Do you understand
Exactly.
what I mentioned? Yeah, that's my old way. I
Exactly.
know.
It's a great use
Yeah,
case.
yeah.
Yeah,
So,
exactly. Yeah, so
mhm,
you have these multiple assemblies that people are working on, but they're
yeah,
sharing in the same coordinate system, so everything is assembled in the right place.
yeah, yeah. And that's my maybe that's my old experience. Yes, but this is I will say I have this skeleton. I will use this skeleton function to build up the ID master file. So because I see your first demo for the 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 maybe the rack for the 3D printer, I think that's really very good to use this skeleton to define and modify. I would say for the design, the most important is we always modify the models because you cannot make it once, right? So that make much easier to modify the file and make everything is correct. Because we all know, based on my experience, the most fear for the engineer and designer is when you modify the file, you mix something. So that will cause
Yes.
some interference and you never find you didn't find. Once into the tooling, you it's too late to to find it out. So that's the thing. We always need to define things and modify the thing. We won't generate everything like 100 process, 100 step in once successfully. That's a achievement for the designer. But we also want to see every setting, every detail is very accurate without any interference after the modifications, right?
Exactly.
So that I will say this is a good skeleton feature. It's a good to define the model, master model. So that will be a good things, yeah, to learn to use in the future.
Great. Thanks, Tim.
Yeah.
Yeah, and also the power of this published geometry feature is this. So if I edit this, so the published geometry feature allows you to collect a bunch of things, right? So you can collect surfaces, which are right here in the surface sets, bodies from your parts, chains, which can be curves or sketches, and then right here, which are your datums, right? So what's great is say that you had a surface, a body, and a chain, and a coordinate system that you wanted to capture all in one feature. You can do that using the
Mm.
published geometry feature. So what's great about that is instead of now, when you create your external copy geom feature, instead of having to, select all of the features within your skeleton part, you can just select one feature, which is the published geometry feature, and it collects all that data at once. Okay. One thing I also want to talk about is notebooks, and I'll open up my blade layout here a second. So I've included more than the blade in this, but this is very similar to like your 2D drawing environment. So basically what I've done is I've created Creo drawings of like the skeleton sketch, the blade, and the blade latch. And I basically exported those from the drawing environment as a DXF and then imported those in. So there's the import drawing data, and I can grab anything here and I could import that stuff in. I could change the properties like the colors of different things from the drawing environment. And then once that here is, what you're basically doing is you're creating these dimensions slash parameters that drive the dimensions of your parts. So for example, I created this blade layout with critical dimensions. So, say for example, you're the designer that's in charge of creating the skeleton model, but you want to be in charge of the skeleton and you don't want to allow anybody to make changes. You can lock all the dimensions that you feel are critical dimensions in your skeleton part so that nobody can change those. And the way you do that is you create these parameters here, and then you go to your part. In this case, would be my skeleton part. I'll just open that up. Then you say, hey, I want to declare that skeleton sketch from the notebook to my skeleton part. So I'll say declare, and I'll select the blade layout that I created. And I'll say, yes, we'll delete the old version. And notice that when I do that and I go to my parameters, this now contains, all of, let me scale this down a bit. This contains all of the parameters / dimensions from my notebook layout, right? So for example, if I go up here, I have this handle front angle 1. So now what I can do is I can go into here, edit dimension. I can change this to be handle front angle 1. Hit enter. Now it says, do you want to add this relation? I'll say yes. So now you can see that's driven from my layout. Let me go back here. So there's handle front angle 01. So now if I change this, you can see that if I go to my tools, parameters, it shows me what that dimension is. If I change this now to 110, for example, get rid of, there's an extra 1 there, and click OK, and I go and I regenerate my skeleton part, that updates, right? But now check this out. If I go to edit dimension and I try to change that dimension, I can't, right? Because that's driven by the notebook. All right, it says dimension Husky Razor knife skeleton is driven by relation D32 equals handle front angle, right? So the person that's in charge of the notebook, is the only one that can change this, right? So now I'd have to go back here to the blade layout and then change that here. Let's go to it's faster to go here for me. And then change that back to 130, for example. So this is great. You can create multiple pages like you can in your Creo drawing environment. And it's just a great way to control who has permission to make changes. And also it gives you a visual on how the assembly was designed, right? So you can say, hey, these are all the sketches, these are all the parts and the parameters that were created from them, so that, when somebody has to figure out how an assembly was created, they can just take a look at the notebook and the skeleton part in the assembly and say, okay, this all makes sense now. I can see where their mind was at when they structured this.
Hi, Bill. Can I have
Yes,
a questions? Sorry
sure.
about to interrupt
No,
you.
it's okay.
Yeah. So can we import the existing DRW or DWG file into this notebook, and they can recognize all the lines by itself?
Yes,
Or you
yeah,
need
exactly.
to or
So
you need
like,
to redraw that? You don't need, right?
so here's all the import options. So it's the IGES, DXF, STEP,
Mm-hmm.
DM, DW.
Mm-hmm.
So if you have those types of files, bring them in.
Mm-hmm.
Yeah, and then you have more control. So if when you bring them in, you can say import options. You say, hey, import, dimensions as a separate entity, as a symbol. And then when you go in here to the properties, you can, change the colors of things. You can say, hey, anything that's, yellow from the drawing, I want to change to, blue, for example, or whatever. Then there's different layers too as well. And then your lined fonts, you can change your fonts. So there is more control when you import your drawing data.
Yeah, that's cool. That's save a lot of money, a lot of time to
Oh, a
build
ton
up
of time.
some, yeah, to build out the parts.
Absolutely.
Thank you.
Sure. Okay, just want to pause here for a second and see if anybody else has a comment or a question. Do you guys feel like you can use this in your current assemblies that you're working on?
Yeah, I had one question. How well does this work with like family tabling stuff? Because we have a lot of stuff that is family tabled that has a lot of the same geometry. Uh, so I feel like this would be good for large assemblies with some of that stuff.
Exactly. Yeah. So I haven't used this a lot with family tables, but I know somebody that has. So for example, I restructured an assembly from somebody that makes transformers, and they basically gave me their assembly before this class I had to teach a couple of weeks later, and I restructured it with skeleton models and notebooks. And later on, at some point, he mentioned that he was using some family table parts, and he was able to make that work. So I'm not sure exactly, what he did, to make that work. But what we like to do is we like to find creative ways to use these tools for any company or person that wants to use them to the best of their ability. So what I would say to you is that we would like to basically take a look at your models and see how you're using your family tables now, and then kind of work through how to incorporate the top-down design stuff that we're showing. That makes sense.
Yeah, just because like if one thing changes, it feels like you have to go into a million different parts to change one little thing. So I feel like if this works well with family tables, that'd be a big time saver for us.
Yeah,
big,
yeah.
big,
I'm sure
big
it would. I don't want to promise anything because it might take some work to get that to work correctly.
Yeah, John, are
Right.
you talking about driving the generic off the skeleton and then having all the iterations on the family table instances update? This will do that. Yes.
Correct.
Okay.
Yeah.
Yeah, I mean it'll do it, but I just want to just make sure that that we like to help you do that just to make sure we're doing it correctly.
Right, you're not just gonna throw us to the wolves if we
Yeah,
get it then.
correct. All right, so let me also switch here to the merge inheritance features, which I think is another powerful use case of the advanced assembly extension. Let me go into my other Creo session here. Okay, so this was a casting part that an engineer created. But what's cool is that, we want to be able to share this data in a way where we can give it to the machinist so that he can make changes to it, right? Without affecting the original model. So this here is the original model, right? But let me go into the other one, which is the merge part. So initially we didn't have anything here. We just opened up a new part. So, whoever's on the shop floor has a license to Creo. Maybe it's a floating license that they can access to make minor changes to parts. So this guy opens up Creo, he creates a new part. And what he does is he goes to get data merge inheritance and he shares into this part the original part. So he would go here, you would find that casting part, click open, and he would assemble it in. My right click is not working as well as it should. All right, so he brings that in here. Now I've already done it. So I have my external geometry feature here. So we bring that in and we use, there's merge and merge inheritance, and I'll show you what the difference is between those. So first with merge, we're gonna merge in the part. So basically we share in the geometry from the original casting part into this part, okay? And then from here, I can make changes. So I can create a cut to this, like so. I can add holes to this, all right? But what's great is, everything that I do to this in this part right here has no effect on the original data. So it's one way associative, right? But if I do change something in the original data, so for example, say I'm the guy that's working on this part of the machine, so I'm like, hey, you know what? I want to make that radius a little bit larger, for example, right? Well, I don't have that data here, but I can ask the engineer that created the part, to select that radius and just increase the size of that a little bit. Right, so now I'll make that change, and then because we have the inheritance feature, I can regenerate this, and it inheritance that change. You can see I bumped out that billet a little bit here. Right, so that's what's great about this. Okay, now let me also open up the merge inheritance, which is a little bit different, right? So the merge inheritance works in a similar way, but what's great about this, and here's the inheritance button, what's great about this is you inherit the features of the model as well. So not only can I make the same cut and pattern of these holes that I made in the other part, but I also have access to the features that were used to create the model. Now, here's the kicker. I can change these things, right? But they add them as a variable dimension, right? So if I click on this, for example, or the whole feature, and I change that to, it says, please confirm adding this dimension to the inherited variable datum table. We'll say, okay, click yes. We'll change that to 17. Okay, so we just increased the size of this hole. And the good thing about that is that if I go to the whole feature or the external feature and go to my varied items, you can see I now have that new value, and I can add more. I can add a value of 18, of 12, whatever I choose to add here, I can do. All right, so I can change any of these dimensions, right? Now, if I make changes, though, I also have the ability to save the source model with these changes by clicking Save Source Model, right? So that's the danger with this option, right? So with a merge, you can't really change the original model, but with this one, I can make changes and say Save Source Model and it'll update. But like the previous version, I can still go back here to the casting. I can, grab that. I can change this guy to 18 if I want, and then go back to the inheritance model, regenerate, and I still get those changes, right? But so this is a great way of sharing geometry, and even with merge inheritance, if you're careful, you probably won't change the original model. But yeah, again, it's a great way to share geometry with people, let them make changes, but it prevents them from updating the original source model. So I'll just pause here. If you guys have any questions, feel free to speak up or comments.
Bill, you're pretty thorough.
Oh, yeah, I think a lot of people have always wanted to use these features or have heard about them, or had the extension but just didn't really have time to play around with it enough to learn a little bit about it. So that's why I want to bring exposure to this.
Yeah, I think this is very great. It's great to know the two different things between the merge and the inheritance. And base, I would say, so I don't know if there are any designers here. I heard some design firms, they don't want to share their like a basic merge file out because they don't want people modify or their client know how they build the model. Is that correct? Do you hear about that?
Oh yeah, I do, absolutely.
Yeah.
Yeah.
Yeah, there's a lot of caution around sharing data because you don't know in whose
Mhm.
hands. Well, you may share it with an engineer or something, right? But maybe you have. I remember when I worked somewhere in Toledo, we used to
Mhm.
make these soft touch interiors, like these vinyls, and it was thermoforming. So we used to have people come in from other companies to like look at our models and stuff that was out on the shop, and we'd want to like share some of the parts on the screen or whatever. So it's nice to be able to open up a part or share a part, and they can take a look at the geometry, but they don't necessarily have the ability to see how you created it, right? So that's a good thing.
Yeah, and we're going to cover something down the road called shrink wrap, which is another way to share data with people without having your design data get in their hands. So
Exactly, Jim. And you know what? That's a perfect time to segue there right now.
Segue away.
um, okay, so that's a great point. So what's cool now too is I'm not sure how many of you guys use it, but in Creo 7 they introduced the multi-body part functionality, and that's great. And other software had it before Creo, but it's a great way to merge bodies together, cut one body out of another, find the intersection between them. But it's also, you can also use a multi-body part for a top-down design where that part becomes a master model for an assembly. That's a whole nother conversation that we can have later. But you can now create a shrink wrap of bodies. So let me show this 1 second. So what I'm going to do here is I'm going to create a new part, and I'm just going to call this shrink. All right, we'll assemble it in. Okay, so there's our shrink part, and I'm going to create my shrink wrap from this. But what I want to do is I'm going to create this external shrink wrap, and I'm going to do my default constraint. Now there's an outer shell collection method. So we want to share this shrink wrap. And we can choose and say, hey, you know what, I want to share the outer shell of this assembly. So I'm just getting the surfaces of the outer shell. I want to do a manual selection. There's also a subset in here, which is great. So if there are components in here that I don't want to include in the shrink wrap, I can turn them on or off here. But what I'm going to do is I'm actually going to use the auto collect all solid geometry. And I will include my internal components. And then here, when I go to option, I can choose bodies, right? And this is what's great is I can say, hey, you know what? I want to create a shrink wrap of all the bodies, but I can keep them separate, or I can merge all the bodies together. So in this case, I'll keep it separate. And then also notice that we have this copy geometry update section down here. So if you have the automatic node selected, it'll automatically update the shrink wrap with changes made to the assembly model, right? And that's because the shrink wrap contains the external copy geometry features that are the link that maintain the associativity to the original assembly of the razor, right? The manual update, what that does is this provides you with a window that pops up when a change has been made. So say somebody modifies the assembly and then you open up your shrink wrap of this, it'll say, hey, there was an update. Would you like to continue? And you would say yes. And then if at any point you want to break the association between your shrink wrap and your original assembly, you can choose this last option right here. I'll click on cancel. I'll use the automatic and I'll click OK. All right, and activate my top level assembly, open up my shrink wrap part. So there it is. So this is great. So now I can share the shrink wrap with people. And if I go to my design items, it has all my individual bodies. You can see each body can be selected. I can hide bodies if I want, so I don't see them. I can hide that handle there. And what's nice is that not only does this prevent people from seeing our IP, right? How this was created, the intelligence behind this. It also makes a more lightweight model, which is great. There's also ways to assemble these in, right? So you can actually replace components of your assembly with a shrink wrap part. So imagine a larger assembly, right? So say you're working on an assembly that has thousands of parts and there's assemblies and they're complex. What's nice is you can say, hey, you know what? I need to share this assembly with multiple people that are working on it. But in order to make their life easier so that when they open up the assembly, it doesn't take too much time to open, or their computer doesn't chug along when they're working because there's so much stuff in memory. What you can do is you can create shrink wraps of the sub-assemblies of a very large assembly, and you can replace the original assembly with a shrink wrap version. Okay, so it really makes assemblies more lightweight, right? But yeah, now I can share this with whoever I want. And also, if it's associative, right? It has that copy geometry ID. So if I go back to the assembly model now, and let's go ahead and adjust the skeleton and modify that, regenerate, right? And I switch back to the shrink wrap, that updates. You saw, this component updated that handle, this component. So at least, 1, 2, 3, 4, 5 components updated in my shrink wrap from that one change. Any comments?
Hey, so this seems to be a lot more useful than how we do it. Is we'll save a copy in shrink wrap, but it seems like this has a lot more functionality to it than when you save, like, make a merge solid.
Exactly.
Yeah. So this actually like creates like bodies from each individual part. Like and
Correct.
then you can turn them on and off because
Correct.
especially with like big assemblies, it seems like if there's like thousands of parts, we're trying to shrink wrap it so we can like decrease the overall model size, because then it takes like 15 minutes to open the entire model. But a lot of times when it's a bigger assembly, it just won't merge all the way. Like even if you set the quality level to like 10, it'll still just like half the parts don't even show up. So it seems like this might be able to handle that better.
Yes, correct.
Yeah.
And also, what's great is that if at any point you find out that you don't need components in the shrink wrap, you can just get rid of them, right? You just go ahead and remove the body. So now that body's gone.
Yeah, definitely useful.
Yeah. Now let me show this as well. So there's the envelope component. Now, in order for this to work, you have to have your master rep selected. So if you have your default rep selected, you can't use the envelope option. But if you turn on the master rep, and you click close, there's the manage views, and in here is the envelope manager. I can create a new one. And what's great here is I can create like an STL, for example, or a tessellated version of anything in here. So maybe, I just want to create like a tessellated version of that handle. I can select that handle here. And in here, you can see there's a faceted shrink wrap. So I can select that and I can determine, what quality, like what's the resolution, right, of that shrink wrap. Let's do 8, for example. Click OK. And then click open and then close. So now I just create a tessellated version, okay, of that handle. So here's what's cool about this. Now I'm going to save this. So you just change the file name, manage file, rename, and let's just call this handle test 03 or something. All right, so that's saved. Okay, so now when I go back to my main assembly, I can go to my handle left and I can go here to replace. So I'm going to replace that current handle geometry with a tessellated version. Now, we wouldn't do this in this scenario because this assembly isn't a large assembly. It's very small. But when it gets to like a really large assembly with multiple components and subassembly, to make it more lightweight, this is one of the things you can do. So then now, I can go in here, I could find that tessellated version. Let's just go into handle left, tessellated, click on open, click OK, and there it is. I might just change this now to default. Now I could always move it later just to make sure it's in the right place, but now there's that tessellated version. Makes sense. I could always go back in there. I can move it up or whatever to make sure it's in the right place, but that's a pretty cool application of using it. So imagine not just one individual component, but a sub-assembly or a large assembly.
But isn't this something you can already do, like without this extension?
Yeah, I mean you can
Yeah.
create step file or a
Like
STL file.
you
Sure.
can no, you can save a copy and do
Yeah.
the faceted
Yeah, exactly. Yeah. Yeah,
and then
exactly.
just
I
like
can go to file,
yeah,
save
that's
as,
how we
save a
typically do.
copy, and yeah,
Yeah.
exactly. But you
Yeah.
have this manager here, so I have
Yeah.
an envelope manager,
Yeah.
right? So I can create a bunch in here, and I can like swap things out. You know what I'm saying? So it's just
Is
sometimes
that
makes it
something
easier
you
to
can only
manage it.
do with the extension?
The envelope, I'm not sure.
Yeah, I've never really tried
Yeah,
using it.
yeah,
I don't
you
know, 'cause
might not have the advanced assembly extension, might not need it
I
to do this, but this is just something I wanted to show you in case you didn't know.
oh, I think yeah, because we
Little
don't
tips
have
and
the
tricks.
extension. I just like looked right now on my own computer, and it seems like it's available. It's like it's not grayed out, so I think I
Okay.
should. Yeah. Okay.
Yep. Yep. I just want to give you little
Yeah.
tips and tricks that
Yeah. Yeah.
a
Thank
lot of
you.
people don't know it's available. Sure. No problem. There's something else I also want to show. Let me just reopen this and just eliminate any problems here. Let me manage session. I'll just reopen that assembly really quick. Okay. The other thing I want to talk about are the interchange assemblies, and these are great. So say, for example, a really good scenario, and Jim talks about this too, which is a really great example, is say that you are designing like a car, for example, and you have an engine, but you have different variations of that engine. So the engine's very similar across the board, but maybe there's just subtle things about the engine that are different, right? Well, what's cool is that you can create an interchange assembly so that you can swap out the different versions for each other without having to redefine the constraints when assembling them. All right. So this is pretty cool. I'll show an example using this blade right here. So I would go to my assembly interchange assembly node and click OK. And I'll bring in my first blade. So there's my blade 1, and then a blade 2, and then my blade 3, right? Now there's a couple ways to find the reference surfaces that we use to constrain these parts, but you can do it manually using the reference tag, for example. So I can say, hey, you know what? I want to use this surface as a mating surface, this front surface as a mating surface, and this right surface as a mating surface, and then go to my reference pairing table, select my original blade, and then also the components to pair. And then what this will do is this will find the corresponding reference surfaces on the components that we're pairing to the original. So if I click on each ID tag, it shows that surface, right? So that's one way. But the cool thing is, I'll get rid of these tags, is if you have a pre-existing assembly already, which we do, right? So we have an assembly here where this blade is assembled, and we have constraints that are already predefined in this blade. Since we already have that data, now all I have to do is go straight to my reference pairing table after importing the blades and say, hey, you know what? This is the active component. These are the components I want to pair, but now let's reference the current assembly to to find out what surfaces we're going to use as mating surfaces. So I'll grab the Husky razor knife, click open, then click evaluate, or create require tag, sorry, then evaluate. And now it read the assembly and it found the original mating surfaces, and it created these tags for each one of those blades. So now what's cool about this is if I go back to my original assembly, I can replace this blade for the other two blades from the interchange assembly that I just created. So I select this, let me get my blade here, replace, and interchange is selected, right? I'll click on open and it opens up this family tree, and now I can grab either blade 2 or blade 3. Click OK and OK. All right. And now there it is. Now this one, I must have changed something because this is supposed to work without any problems. Let me try the other. I probably modified something in the assembly. Let me try blade 2. Why? Okay. Yeah, I think it's reading that one that I just created and not the old one. But yeah, this will open up and it'll create it without any problems. Let me actually just clear everything out here, just to show that that works the way it's intended to. All right. I didn't save that, so it should be fine. Blade. Blade define assembly master. Let me try it now. Huh. It's not reading that, but I guarantee that it works. Let me just try to just create a new one real quick. If you guys have time, is that fine?
You made changes to that assembly, which might be screwing you up, Bill.
Oh yeah, I wonder if I.
Yeah, you modified it.
Oh, I modified it, but yeah, I can go back here real quickly. I'll just do a new one. To the interchange. Change 03 just to create a new one here. And I'll bring in this blade. It's good you guys get to see it in real time too. So then blade 3. Okay. Then I'll go to my pairing table and we just grab the original, these guys, and then we bring in my Husky razor knife, evaluate these, that's good. Click OK. All right, let me save. And then let me go back here to the main assembly, replace, interchange 3. There it is. So it worked. Thanks, Jim. Appreciate it. I didn't realize that I changed the original. Sometimes when you're working fast, you make mistakes.
That's okay.
Yeah, so any questions about that? Do you guys have any large assemblies that you're working on where you feel like, you know, you have some components that are very similar? Maybe it's an engine, maybe it's a suspension of some
electric
sort. It could be
motor.
anything. Yeah, exactly. Perfect example.
Yeah, an electric motor or an engine or whatever. I mean, where this really accelerates, time is the bigger and the more complex. I mean, something like this with the knife, it shows you the example, but You're not going to save that much time, but when you're talking about bigger, more complex items, we have customers that swap out engines on trucks, and everything updates: the wire harnesses, the manifolds, the exhaust manifolds, the exhaust piping. I meant everything. So all the bill of materials, all of the assembly drawings, and they have specific work instructions for the shop floor. They all update. So that's where you
Amazing.
get the accelerated time.
It seems like what you just showed is similar to like creating like a family table of each of those blades and then like assigning a component interface to them, and then that will just auto update it. It's like another way of doing it, I guess.
Yeah, exactly. And to your point, let me show you something. So here's an interchange assembly. If I go to my reference pairing table, one thing I didn't show is let's see if the evaluate is here. Let me just show that again. So there's the evaluation rules, and you'll see it has the component interfaces. So that's exactly what it's using. It's using that technology from Creo to do it.
Okay.
So I can kind of hear your wheels turning.
Yeah, no,
Are
it's
you
just
thinking about ways
because
to
like
apply this?
we typically will have like, especially with hardware, we'll use it like screws and stuff. We'll have the component interface for like the bolt head, and then like the shank, and then we can just replace, like if we want to change the length of the screw, you just go on the family table. It's like table driven all the lengths and diameters, and you can just instantly like change the bolt pattern to have like a longer thread, and you don't have to like reconstrain anything.
Exactly.
Yeah.
Yeah. So that's a great use case. So you're combining the component interface with the family tables. And for those of you who haven't used the component interface yet, it's basically a way for you to predefine your assembly constraints on your component before you assemble it, so that when you do assemble your component, you don't have to select the references on the component you're assembling, only the references on the component you're assembling too. So for example, you can see that I have a footer here with my interface. I have one here for the head of the underside of the head of this, and plus this cylindrical surface, right, of that fastener. And to do that, you go to your component interface group, then you predefine these here. So you would say, for example, hey, let's create a coincident constraint here, and then one here for that surface, and then click OK. Right? And then basically what it does is it creates this footer. So now if I want to go back to my assembly, and I'll just hide this one. If I want to assemble that in, I can go to assemble, and where's that? Here it is. Click on open. So now I don't have to create or select the reference on the fastener. I just select it here on this component, like that, and it's assembled quickly. So yeah, so what you've done is you've just created those interfaces and then created your family tables alongside them, right?
Yeah. Well, it seems like what you showed before was like kind of similar to doing that, because you have like 3 separate blades that had, I guess they had some differences to them, and then you put them all in that interchange file, and then
right.
Yeah.
Exactly. Well, great. Yeah, it's cool to see that you're already starting to figure out or think about how to use these features.
Yeah, it seems like it has, because it seemed like there was more functionality to the way you would showed it, because it had those other parameters, I think, if I recall.
Exactly. Going back here.
Yeah, like when you went.
Yeah, family tables is very limited. Number one, and you should only use family tables in certain instances. It's not good practices, especially for you guys. Show you guys aren't using Windchill yet. Yeah, so you know,
that's a whole nother story.
Yeah.
So
no, but that's a great point, because you're inheriting all this other stuff too, right? The history, the same parameters.
Well, for
ID
us, we have like we have like a search path like in our config to
Yep.
like this fake like master like hardware like directory. So like
I see.
if someone like creates a like a screw or like a nut or something, then like everyone has access. Like you don't have to like load it in every single time you like open
Right.
Creo or put it in your
Yes.
directory. You can just kind of
Right.
Yeah.
it'll just like read that folder, so then everyone has it. So that's like our
Right.
fake Windchill.
No, yeah, totally. No, yeah, I've seen it before.
Yeah.
It's just a config option that you add
Yeah.
here.
Yeah, it's just like a search path.
Here it is.
Yeah, it's one of those, I think. Yes, I think it's the one at the bottom. Search path underscore search
Yep.
underscore path. I think it is.
Oh, here it is. Yep.
Yeah.
Yep.
Yep. Perfect. Okay. Well, anybody else have any questions? Feel free to ask, or any comments, or we also, if you guys have any feedback too, as far as what other workshops you like to see. I know that we're planning on doing a surfacing one, a simulation one, maybe a
I've got
reverse
a-
engineering.
I've got a survey, Bill. I'm gonna stop the
Oh, okay.
recording.